Is there another way that we could think about doing this problem? Now, let's keep in mind the definition of acceleration. Acceleration is the change in velocity over a certain amount of time. So, the acceleration of 2 meters per second squared is equal to the change in velocity over a certain amount of time. For every 1 second, the velocity changes by 2 meters per second. That's what acceleration is. It's a change in velocity over a certain amount of time. So let me ask you this. Now, once again, we keep in mind that the initial velocity here is 20 meters per second. So at 0 seconds, what's the velocity? 20 meters a second, right? After 1 second, what's the new velocity? Keeping in mind this definition, for every 1 second, the velocity changes by 2 meters per second, which is what acceleration is. So after 1 second, what's the new velocity? 22 meters per second. Well, what about after 2 seconds? 3? Hopefully you're seeing the pattern right now. And once again, we get our answer of 30 meters per second as our final velocity. Hey, so that's, by definition, that's what that means. That's what acceleration is. Okay, well, we solved it in this way. This is interesting. So, what about another way? Look at this formula right here. Have you seen a formula kind of similar to this? Well, what I'm going to do here is this. I'm just going to rearrange these two terms right now. Let me just rewrite this. Just like this. Have you ever seen any formulas, any equations looking like this? Well, yeah, you have. Have you ever seen this equation before? This is the slope-intercept formula, where the m represents the slope and the b represents the y-intercept. And I'm sure by now that you've actually seen this formula before. Okay, well, let's do this. What's the value of b? Well, that's the initial velocity, which is our 20 meters a second. So let's just say here, this is our 20 meters a second. How do we go about plotting this on a graph? So we have our VF is equal to our slope, or our acceleration, times our delta t. That's going to be our input variable, plus our b, which is 20. Okay, so what is slope? It's rise over run, right? So we rise 2 and go over 1. Rise 2, go over 1. Rise 2, go over 1. Rise 2, go over 1. Bam, and we get our line. So, hey, you know what? This is just an alternative method, but once again, rise 2, go over 1, that's at 22. Rise 2, go over 1, 24. Rise 2, go over 1, and that's 26, 28, all the way up until 30. Where the time is equal to 1 second, 2 seconds, 3 seconds, 4 seconds, and 5 seconds. Notice once again, we have at 5 seconds, our velocity is equal to 30 meters per second.